Pratibha, I cannot hear you.
Now also you can't hear me.
Yeah, now I can hear. Tell me.
I'm saying why you are sharing this screen.
It's why? What happened?
This is ICC na.
This is Internet of Things third tutorial only, right?
Yeah, that's correct. But you are sharing a ICC consolidated sheet.
Really? Oh, thank you. Oh my God. Yeah, now is it okay?
It is fine.
Ah, thank you, thank you.
Sushmita,
Yeah, tell me.
nothing about that. What lunch and snacks. We can order now also, na?
Hey, text me here, Pratibha.
Okay.
Hey, Sushmita.
Yeah, Ditanu.
You started very early, I think.
No, half an hour before we are supposed to start, no, and wait for them. So that's what I've been doing.
Um,
Yeah.
Yeah, hi, Sushmita, can you hear me?
Yes, sir. Sir, am I audible? I can hear you, sir.
Hello?
Hello? Am I audible?
Hello, sir. Am I audible to you?
Pratibha, can you hear me?
Yeah, yes, sir. I can hear you. Hello, sir.
Hello,
Can
sir.
you? I can hear Sushmita and Pratibha well.
Is audible?
Hello. I think we are not audible to them, Raj.
Yes.
Yeah. I think we should.
Could you call him and tell him?
Yeah. Yes, sir. Yes.
Or we can message here in the chat.
Yeah, we can put it up on the chat.
Yes.
What do I say?
I'm writing. I'm writing.
Yeah. Please do. Please do.
It seems your.
Is it not? I can hear you. You can hear them.
Yeah, we can hear.
Okay. Can you hear me now, sir?
Yeah, we can hear you. It's just
Okay.
that
Great. Great. So this is all fine. Thank you.
you can hear us?
Yes. Yes. Loud and clear.
Yeah, okay, thanks.
Thank you.
Yeah, thanks.
I think unmute your mic. Your host has spotted your. Would you like to unmute the mic?
No.
Yes, microphone is visible. So right now you're not visible. So that's possible. Now it changed. So after you interview, maybe you can switch a spot later.
Good evening, everyone. Am I audible?
Yes, sir, you're audible.
Okay, thanks. So I think we can start this session, the third session on this tutorial on Internet of Things. I think we have some participants, so I don't want to delay further. It's already late in the evening, and some of you would be tired attending many of the sessions. In any case, I am Raj Babu. I also am playing the role of this session moderator, but I'll start off this part 3, and then I have with me Rohit, who's from the e-Yantra team here at IIT Bombay. So in some sense, this tutorial is a joint effort between us, and also, as you know, this is supported by TIH IIT Bombay, that is Technology Innovation Hub at IIT Bombay, and this Technology Innovation Hub is on Internet of Things. So this is why this session is supported by them, and we would see more about what this tutorial and how it fits into the bigger scope of things. So just to briefly mention, some of you would have attended the earlier sessions, one in the morning, which was where you were introduced to Internet of Things, and also the role of sensors in IoT. It's presented by Professor Siddharth Nallur. The second, which happened in the afternoon, which was on networking of IoT nodes, which dealt with the communication and networking aspects of IoT. As you would have sensed from the description of IoT, IoT itself is a very broad area covering several aspects. And what you had seen in the morning 2 sessions is essentially, if you look at this triangle on the right, physical sensors, a bit of sensor interface was introduced through the theory sessions, more focusing on the choice and design of sensors, which is very traditional. And then in the second session, it was more on the communication, either between the IoT nodes or the IoT node and to a server. So given this breadth and the things which has to be covered in an IoT, the other top areas in this triangle, which are mentioned as analytics and services, is quite a bit to cover in a tutorial of this nature. So what we have instead planned and what we will demonstrate as a hands-on session is a lab session covering this, what I would say, the basic building blocks of an IoT system. And we'll see more about this. Of course, we will try to provide the context as to how this IoT can be enabled. This is more centered towards, there may be some of you who have quite a bit of experience in embedded controllers. But this session is intended so that you kind of get a quick start on some existing microcontroller-like device, which is enabled to do IoT, and then how to put things together and up to the level of, let's say, once you have this microcontroller and you have some IoT node connected to it, how do you kind of collect data from these sensors and where this data gets collected, what do you do with it? Right? So we may not have time to go beyond beyond this. That is the data analytics part or a specific application using it. So that with that kind of brief, I would say, overview or maybe outline of what this session is going to be. So we will go through this microcontroller device, which is actually from Yantra. You'll know more about this soon. And we will interface very simple sensors. Because in Professor Siddharth's talk, there is no explicit mention to all these kind of sensors, but I think we talk more about accelerators and a few other sensors which are used in practice. But we will stick to this temperature, humidity sensor and think of as if we want to kind of develop a weather station, right? And then what this weather station does in terms of logging this data. So ideally, if it had been a practical, we could have provided this to participants, and you might have been able to follow us, and you could have done it. But given this kind of remote and virtual lab, we have tried to do whatever best we could in terms of mimicking a walkthrough. So let's get started, and if there are any questions, please feel free to stop in between. So I'll now hand over to Lohit, who's going to kind of conduct this session, and I'll be around, and we should be able to have a hopefully a fruitful session, though it's a little late in the evening. Yeah, Lohit, you can.
Okay. So I should be audible, right?
Yeah.
I'll just switch. Okay. Right. So I think most of you have understood what Internet of Things is all about. Our main focus for this session is how do we use microcontrollers and sensors, to log data in a remote server. So this is the basic architecture of any IoT system that you would like to build, right? So you have sensors, and the sensors are normally connected to some microcontroller or a processor. There are multiple protocols that one can use. So in this kind of a demo walkthrough, we have used I2C and UART, for communicating with the sensors itself. And important feature or ability that an IoT system should have is a storage element, because we want data, and data is what makes IoT so interesting and famous. And even though we are trying to showcase, building this minimal weather monitoring system, such setup can be used for even logging interesting information, because this is a control system conference. You can definitely use such logging of data if you're building some complex system and you want to investigate if there are any possible errors, right? So such setup can be used as well. We use weather as a you call the hello world of IoT. Anybody wants to give a demo on IoT systems, weather station is the simplest one. So that's what we are trying to do here. So storage, and then the most important part of IoT is the internet itself. So there's a lot of work going on with respect to how to push the data to wherever you need. In this context, the cloud. But it need not be the cloud. It can be a local server. It can be another system that is sitting close by. So you need some way to communicate with each other. And there are a lot of protocols. And I think Professor Gaurav spoke to you about co-op. That is more used in industrial setup. But for a beginner MQTT is used. And for this demo, we have used HTTP. So this is what a system is, and we'll be focusing with respect to the sensor, the microcontrollers, storage unit, and how are we sending it to the cloud itself, right? So again, this is just a bare minimum. You can have multiple layers also part of this. So in this exercise, right? So me being from Iandra, Iandra is located in IIT Bombay. It's a project funded by MHRD. So what we want to do is build a custom board which can be used for. So the board is here, and I will tell something about the board very soon. What it can do and what it can't do. So in comparison, there are a lot of devices there out there which enable you to do IoT based application. ESP has its own protocol now called ESP now. Arduino is having its own Arduino IoT platform, right? Raspberry Pi is a well-known gateway for IoT systems. Intel is getting into this domain, right? There are a lot of IoT devices available there. So what we try to do is build a much low-cost device which can enable people to do some simple IoT-based applications. So if we have time, there are a few videos which shows real-time application of this board, which we will cover later. Right. So this is a board that was designed. Quickly, these are all the benefits, and the best benefit is the over-the-air update. Because most of the time IoT systems are at remote places, and it doesn't make sense to go to the device and connect it and update the firmware, right? So over-the-air update is one of the features that we have worked on. Apart from that, there is onboard storage that is very important for IoT applications, like I mentioned in the previous slides. So what this board basically constitutes is two well-known MCUs, that is the Atmega and ESP32. So in specific, Atmega, we use is 2560, Atmega 2560. And this particular board also has a provision to output 12.5 watts of power. And since it has a ESP and ESP32 supports FreeRTOS a lot, that also has we do have capability to port RTOS onto the ESP itself. And the way ESP and Atmega communicates with each other is the UART protocol. So if the reason why we did this combination, this combo, was we wanted if one needs to interface a lot of IO devices, then it is available on the Atmega 2560. What is not available on Atmega was the wireless capability, which allows us to connect to the internet. So that was given through the ESP module itself. So this is like twinning both the need for GPIOs and the need for Wi-Fi devices. So this is what the specs of the board itself is. Also, there are a lot of toolkits that we have built up around this system. We have a lot of sample codes. It is ready for VS Code platform. It is ready for Arduino IDE. That's what we'll be using for demoing this part of the demonstration. And you also have, we have created a toolkit for SimulID. So you can use the simulator and mimic the whole thing without the hardware. So all this is what was developed here at IIT Bombay. This is how the kit itself ships if you are interested to buy. And yeah, it's not a marketing thing, so that's fine. So what we're going to do in this setup is pretty straightforward. What we have is two devices. So one is right here, and to this we have the OLED interface, right? And then apart from that, there seems to be some lag. Okay, yeah. So this is another system, and for this we have interfaced CO2 sensor, and this is our BME 280. So this is what we have interfaced, and to be clear, BME we are using I2C. For the CO2 we have used watt, and for OLED again we have used I2C. So this is what we are going to give a walkthrough, and we are going to use Arduino IDE for programming this board, right? So like I said, this board is completely portable with any environment that you want to use it for. So what we're going to do in this demo is we have these two devices, and one is going to act like a server and the other is a client. And during this communication, we are also logging the data onto Google Sheets. So in our effort, so this is the basic setup, right? And we will see a complete working demo of this towards the end. So the reason why I said Google Sheets is to avoid the use of using the cloud platforms. So many of you know, if you have already used any cloud-based services, you have to provide some billing information like your credit card. Even though there are all the gray parts in this slide, the gray blocks are all the benefits of cloud. But there are drawbacks of cloud as well, which is data privacy, lack of technical support, because a lot of people, a lot of projects are using cloud services. So there are a few drawbacks of cloud, and one of the main things is the billing itself. That's why we went forward and built a complete ecosystem based on free open source tools. So the IoT framework that we are using is built upon ESP-IDF, and we are using currently, I can't say Google Sheets is free, but as of now it's free, and there is no billing information. You don't have to provide any credit card information. So it's much portable for testing out and implementing your applications. So this is what we have used. GitHub is the way we are doing OTA. We use since it's a embedded and IoT based system, you need real-time UTC timings, and so all that is available through the NTP tool. Apart from that, we also use since I mentioned MQTT needs a broker, and Hive MQ is a free open source MQTT broker. So all that we have used is free open source as of now, and that's what we're going to do. We are going to push the we're going to read the sense data and push it to Google Sheets, and we also can send emails to our members who are subscribed to this service. If the temperature goes beyond a certain threshold, you basically get an email notification. So this is what the complete framework itself is. Even though we are not, we're not going to show the IoT framework with respect to ESP C++ code, because it can be a little complex. So what we dealt to simplify the whole, the motto of this is to build something and see and put it to use. So we have used Arduino IDE for the whole setup. So so this is a little bit about the I2C protocol. Okay, am I audible? Yeah.
Yeah.
Yes.
Sir. Yes, sir.
So so I2C protocol is what we use. I2C has the capability to interface multiple devices on a single two-wired connection. So based on the address, we'll see in the demo, based on the address of the device, you can communicate with the device using a simple two-wired protocol using SDA and SCL lines, right? Apart from that, we also have a lot of, you know, the speeds that you can attain using I2C is is very fast compared to at least UART. So there is a simple speed comparison given where SPI definitely does better than I2C, and I2C is better than UART itself. So this is what we have used. So I just wanted to put this here so that people are aware as to what I2C protocol is all about. So yeah, so let's see how we can.
Yeah, so before Rohit continues and goes forward, so maybe at this point, we would just like to know if among the participants, how many of you are kind of already familiar with the microcontroller and have used anything in kind of an IoT setup? If you can please, I think you should be able to use this raise hand feature and just click raise hand. So that I'll just take a quick look at how many of you have done or used, so that we get a sense of the participants. And of course, we can't change too much, but at least we know the audience we are talking to in terms of such a hands-on session. Because the whole idea is if we could convince, I mean, even those who have used a microcontroller, here is what minimal you have to do to make it an IoT. That's one. And the others, for those who are not very familiar with microcontroller and what IoT is, maybe here is a platform which you can get started with, and later when you go back to your school or your research, whatever it is, these things will be useful. Yeah. Okay. Yeah. Thanks. I think 5 to 6, maybe the others or virtually there. In any case, thanks for the hand raises. You can now please lower your hands and we'll continue the session.
Yep. So let's see how to first interface the BME 280. So these are the few. The reason why people use Arduino IDE is the availability of libraries, right? And every sensor that you buy off the shelf will have an a library available to you. So that's what we also have tried to use to show that it's much easier to develop such things very quickly. So interfacing BME, like I said, we have used I2C, and there are a few settings that we need to do, and that's the first function that allows us to do that. And then you can read temperature, pressure, and humidity from the sensor itself. So so these are the basic or the minimal function that you can use for programming or reading the sensor data from BME 280. So quickly, let me just jump to the Arduino IDE, and then let me just get that. Let me start the sharing again. All right, I guess my complete screen should be visible now. Let me, is this visible?
Yeah, yes, it is visible.
Yes, we can.
So does anybody want me to increase the font size? Is this fine? Okay. So, so this is what the library I was talking about. This library allows us to use a lot of APIs, which I showed a while back. So what this code is going to do is, this is a basic setup of Arduino. I don't want to get the details. So you have two main functions, that is the setup and the loop. So setup is basically the initial initialization that you want to be enabled before you even start, right? So we are going to use serial COM for checking the data that's been put out. And then this BME.begin, this 76 that you see, right? This is the I2C address of BME itself. So the way you check if the BME is connected or not is by checking if we can ping to this address and see if it's connected to it or not. So if it's not connected, then it will just throw an error and just stays there, right? So this is your I2C address for that. And like I said, it's pretty straightforward. So all you need to do is, so don't worry about this. This is just to print the data onto the serial port, which you will see right now after I flash it. So the way you read the temperature from BME is, BME.read temperature. And then it returns. So BME is the object that was created using the library itself. So this is where we created the object of that library. So BME is the context for the device itself which is connected. So so when I say BME.read temperature, it basically reads the temperature of this BME that is connected to the I2C I2C to wire, right? So yeah, so this is for temperature. Similarly, we can read pressure. We are just divided by 100 because it gives the number is too huge, so we just truncated it. And then we have a provision to read altitude. This altitude is basically with respect to the pressure change. So it may not be the right way to read altitude, but definitely pressure, temperature, and humidity is accurate for the BME 280. So similarly, BME.read humidity. So all these are the functions that are provided by the library itself, right? So this library. So if one has to go to this header file, you will find all the functions that are available for usage. So this is a simple code, nothing complex. So this whole thing is inside a loop. So this continuously reads the sensor data and puts it on the serial COM port, right? So let me quickly flash it. So this is the device that is currently on, and I have connected this to this laptop that I'm using. So it's already connected. So I'm going to just upload the code. So this is to this top arrow that you see a yellow color is the way you upload the code. So I'm just uploading the code, and once the upload is done, we will switch to the COM port to see the data itself. So each time it compiles and then flashes the code onto the board itself. So the upload is done. I'll just open the COM port. Baud rate is set to 9600, right? Setting the baud rate. So we can see the temperature. I'll just stop the auto spooling for a while. Yeah. So these are the parameters that was returned based on the functions that we used, right? So temperature, pressure, and humidity. Towards the end of this walkthrough, we will see all this data pushed to Google Sheets, right? And then we can also see how you get email notifications. So this is how, and since it's in the while loop, like I said, it continuously broadcasts data. I can change the temperature and show, but we'll do that change later when we put all of these pieces of codes together for the final demo. So yeah, so this is what this is how the BME itself is interfaced to the board, right? So it's pretty straightforward. It is straightforward only because we have all these APIs available with us that people have developed and contributed towards the Arduino ecosystem itself. So yeah, so I think next sensor that was to be discussed was the CO2. The golden thing that you see here is the CO2 sensor. So this also uses UART. So you'll have to the way it establishes the connection is by giving the UART details to it. So the basic function, like we saw begin BME.begin in the BME case, that is to establish the connection with the I2C itself. Here, .begin says establish the connection through UART, and we have to give the UART TX and RX pins. So in UART, basically you communicate using TX and RX, right? So apart from that, CO2 sensor needs some way of calibration. So we have to enable auto calibration that will enable ensure that at least the sensor data that are coming in is acceptable. And the other two functions that we predominantly use with this sensor is get CO2, and this will give you the CO2 in ppm. So that's how you measure. You take readings in ppm for CO2. And this get temperature is not the temperature of the atmosphere, but there is a working module inside the CO2 sensor. It's cased, right? So sometimes the temperature can go out of hand, and by just checking the temperature of the device itself, we can see if the readings are to be trusted or not. So that's why they have given this get temperature. So this get temperature is not with respect to the environment temperature. So just a correction there, right? So these are the functions, and we'll quickly see how this goes. So I'll just close this down and open up CO2. Yeah. So this is the Arduino code for CO2. Here we have used this library, like we saw the Adafruit underscore BME, right? So that was for BME, and for CO2 MHZ19. So if you're wondering what MHZ19, this is the model of CO2 sensor that we have used. There are variations of CO2 sensors available, but the one that we used is MHZ19. And we have since this board has ESP, and we have used for the internal communication two of the UARTs. It is suggested that you create another software based serial port, UART port, by deciding two pins that can be used for RX and TX. So that's what we have done here. It's a simple software serial function. So this creates UART. So this serial you see here is a inbuilt function that is provided by Arduino. So if you're using, like I said, there are 3 UARTs, right? So if you want to use the inbuilt Arduino serial port functions, then this becomes serial 1 or serial 2, right? Depending on how many serial ports are available. So we have used serial.begin. This is to check the or basically push the data onto the COM port. Apart from that, we're going to use this software serial to communicate with the CO2 sensor on these 2 RX and TX, right? So that's what we are trying to do here. So yeah. So the baud rate for both the CO2 sensor is also 9600. So the baud rate is 9600. So this my serial is the software serial UART that we created using software serial, and we are going to connect or start the communication between them on this serial port. And then once the serial is started, we're going to tie it up with the sensor itself. So just remember that in the first, I had said that begin, and then the stream, the address of the serial COM is passed here. So after that, immediately we need to give all this in the setup. So we need to give an auto calibration, so that calibrates based on its internal compute power. So after auto calibration, it starts pushing out data. So this is the basic thing. And then to read the CO2 sensors, we are going to use this small piece of logic that is written here. So this is the function that I mentioned a while back. So get CO2 is what fetches the CO2 value in ppm, right? And there is the temperature of the device itself that is read here. So we have set an interval for reading because based on the data sheet, we should not read it continuously. So there needs to be some delay before we read the CO2 sensor value. So that's why we're given this time lapse. Okay. So this is the simple code. We have just used the same functions that I showed in the slides: get CO2 and get temperature. So I'll flash this code again. So it's both these two are on this particular device. So I'm not changing the cable. So I'm going to flash it again, and we'll see the COM port. Let me just close the COM port if it's open. Not open. So I'll flash it again. So by uploading. So this is one drawback of Arduino IDE. Each time it compiles and then pushes. If you're using VS Code, you don't have to worry about when you're flashing, it only flashes, right? You don't have to compile it each and every time. Even though I've not made any changes, it still does compilation and then pushes it over to the board. Okay, I think it's done. So let me open up the COM port. So yeah, so this is the CO2 right now. It's there are not many people in the lab, so it's pretty normal. So as soon as somebody blows into it or tries to, if there are a lot of people accumulating here, then definitely the CO2 will change, right? So yeah, so if you had seen that in the previous, I think it was 28 degrees, I'm not sure, but here it shows 30. So this is because it's the sensor is inside the casing, and it's recording the sensor of the device inside. So yeah, so this is how the CO2 is interfaced, right? Okay, let's close this, and the next. Okay, before we go to OLED, is there any questions or queries? All right then. So we have tried to use OLED only for showing that we can send information to an end device, which can display the data. So the final demo will basically show us sending the information of the right now I've changed the board. So from here we will basically send it over to OLED. At the same time, we'll send the data to Google Sheets as well. So OLED is a very nice device to troubleshoot as well. So like I said, we have used I2C here as well. But here it says 0x3C, but it is not 0x3C. The address for this particular OLED is 0x78. Right? Remember, in BME it was 766, and the I2C address for the OLED was 78. So the only information that we need to give to get started with OLED is the pins which is connected, the I2C is connected to, and then basic information that you want to give. And this library that we have used supports two kinds of OLED displays, the SST1306 and SH1106. So most of these parameters are not mandated to be given, but obviously you need to give where the device is connected to, basically the I2C pins, the SDL and SCL lines. So if anybody is wondering what SDA and SCL is the clock, and SDA is the data line. Yeah. So so that's what and there are since it's an display device, there are a lot of functions that are available. People have you can use this OLED to play a simple Mario game as well. So there is a nice little demo that we will see soon, that OLED can be used for gaming as well. So this is what the simple the function that we're going to use. And like I said, there are a lot of functions available, but we'll be using whichever is sufficient for us for our use case. So right now we see some information here, right? So don't worry about this. This is running the old code. We'll reflash it and see what we are going to display on this device. So let's quickly jump to. All right. Let me close this. Sorry, folks. Right. So this is the code. This is simply trying to display welcome to ICC 2021 tutorial session. Right. So all we're going to do is just display this much, and then actually in the final demo we will see just like this, right? But right now the sensor values are not changing, but you will see data coming onto this OLED from the other device, right? So yeah. Okay. So we have this device, and the way you communicate is through the begin, and we have the I2C address. Apart from that, this is what I said. There are a lot of functions. So this is going to set text size, the color, where it should start displaying the content that we want to display. So apart from that, where is the yeah, so this is what I was talking about. So this is the information that you send for configuring the OLED itself, right? So this is how you communicate. And if you're wondering, C3C, it is in hexadecimal, but it is actually 78. Okay, anything else that I missed here? No, that's it. So, so what we're going to do is just flash this, and we're going to see, this particular text on the display. So since I've used different, the COM port may have changed. So I'm going to choose COM port 7, and then I'm going to flash this port. So meanwhile, this is happening. So we have just set up an Google Sheet, which will take data. So if you're interested to get a notification if there is a weather change, yeah, so I think it's flashed, and you can see that it shows it's not clear, but it does say welcome to ICC 2021 tutorial session, right? So this is what the complete interface is. So what we're going to do is now look at the overall use case of using two sensing devices, one output device, which is basically trying to display whatever is read, and then we'll see how to push the alerts as well. So before that, let me just share this sheet so that if you're interested, right, you can put in your email address here, and in the demo, we'll just try to vary the temperature, and if it goes beyond 65 degrees, for change the temperature, we'll just use a hair dryer, and that changes the temperature. And if it goes beyond 65 degrees Celsius, then you should get an email. So I'll just share this sheet in the chat if anybody wants to put in just for making it interactive. So if you really want to see if you get the notification, then you can just put in your email address. We will definitely show the alerts on these two email addresses. But if you want to put your email address, you are welcome. So yeah, let's see the complete demo. So for the complete demo, I have Isha with me, who will give you a walkthrough of the code itself, right? Is anybody able to access this? So if anybody wants to receive emails, please do put in your email address. Or if you're not able to get access to the sheet also, you can just raise your hand if you're not able to get access. Okay, you don't have access to it. Okay, let me just change the permissions. Sorry. Okay, I have given permissions to everybody. Please don't edit the sheet 1 because this is where the data will be populating. Please put in your email address in the emails subsheet. Right. So meanwhile, Isha will just set up the and flash both the devices so that we can see it in working. It's in the chat. Oh, it's a direct message. Sorry, I just put it to direct message. I'll just send it to everybody. My mistake. Okay, now you should see the link.
So here you can see that we have two E5 mega. So we will be communicating between these two E5 mega boards using using HTTP protocol over Wi-Fi. So what we have here is, so on one E5 mega we have two sensors, but for now we will not be using CO2 sensor because we have a last minute issue in that. So we'll be using a BME sensor, and we'll take three values from this sensor: temperature, humidity, and pressure, and then we'll send these three values from this device to the another device which has OLED, and that data will display on OLED, and simultaneously will log that data into the spreadsheet so that we can monitor that data and send the alert notification to the user so that it can so that he can user can monitor that, get the environment data. So both these devices will be connected to the Wi-Fi, and both these devices will be communicating using HTTP protocol over Wi-Fi. So for these devices to be connected to the Wi-Fi, we'll be using this Wi-Fi.h library, and for communication using HTTP, we'll be using ESP async web server.h library. So other libraries are, I think you guys are familiar with that because already Lohit sir has told you about the BME library and OLED and OLED, because we are not using here CO2, so we will not be using MHZ19 library here. So all these things are similar, RxPin and TXPin initialization and all that. So we'll see. So this is the code for the calibration of the CO2. But will not be using a CO2. So the next thing is we have written a separate functions for reading the three different values: the temperature, pressure, and the humidity. And to continuously send the data from this device to this device, we'll be using a HTTP protocol. So for continuously sending that data, we'll write these lines of code inside a loop function. So this is that. And then so this is the so here you can see, so this is the SSID and the password to of the Wi-Fi to which this device is connected, and to send to receive. So this device wants the data from this device. So so for the communication, this device will need the address of this device. So we'll get the IP address of this device using the Wi-Fi.local IP function. So once you get the IP of this device, you can put that local IP in the client code, and then you will be able to connect to this device. So basically, the device which is generating the data, it is which is generating the data and the sending is a server, and the device which is requesting the data, it is client. So here we have a client, and here it is a server. So for sending the data, we'll use a server.on function, and once, so if the CO2 is the root, so if the temperature is the root, it will send the temperature data. If the pressure is the root, it will send the pressure data, and if the humidity is the root, it will send the humidity values. So here the next thing is so in HTTP there are some request methods which are get, post, put, delete. So if client wants the data from the server, it has to use a get method. So we'll use a get method here. Then the serial com will print that the request is received from the client, and then we'll send a 200, which is the status code. If the server is successfully able to send the data to the client, then it will receive, then it will send the status code as 200. If the server is not able to send the data to the client, then it will not send the status code. So here we are sending a plain text value. So that's why here the content type is text plain. And if we are sending a JSON data, then it will be application/JSON. But here we are sending a plain text. So that's why here it is text/plain. And here the next parameter is the value which we are going to send. So this is a server side code. So on the COM code, I think you can see the values which are generating. It is not connected to Wi-Fi yet, so just reset. So now you can see the values are generating. Then the next thing, so here is the client. So here you can see that the temperature. So if the device want a temperature value, then here it is the protocol HTTP which we are using, and then this is the IP address of the server on which of the server, and this is the root. If this device wants a temperature value, then it has to be a temperature. If this device wants a humidity, then it has to be a humidity or the pressure. So this is the same as the Rohit sir has mentioned about the OLED functions. So this is all. And in setup, we have initialized the Wi-Fi and the OLED display. And in the loop function, we continuously wants the data from the server. So that's why we are writing these lines of code inside the loop function. So we'll go line by line. So here you can see that we are getting a current time, and I want the data to be logged into the spreadsheet at every 10 seconds. So I have put initially I have put at interval as 100 milliseconds. So if so here I am getting the current time, and it is the previous milliseconds. So here, as we go down here, you can see. So as soon as the data is logged into the spreadsheet, it will get that time. So it will store in previous millis. It will store that time, and it will calculate the difference between the current time and the previous time, and it will compare it with the interval. So if it is greater than or less than between the specified interval, it will go inside this function, and again it will log that data. So here you can see that HTTP GET request I have used. So what this function does is, we have created a client object, and these two devices will be communicating using HTTP. So here I have created the HTTP object. Then we'll start the client. So client and the server name. So server name includes the IP and the root. Okay. So as you can see in the loop function, first I want the temperature data. So it will go inside HTTP GET request function. It will start the client. It will send the IP address and the root. Then it will send the GET request to the server. And when client sends the GET request to the server, it returns the response code. So if it is successfully able to get the data from the server, it will receive a 200. It will receive a 200 as a response code. Or if there is any error from the server side, it will give you the status code as -1. So whichever data you will be getting, we'll be storing in the payload variable. So if you are getting a 200 response code, which is success, so we'll read we'll read the data using getString function. So this will return. So using this function, you can you can get the data as a string. So we'll store that data in a payload variable. And if there is any error from the server side, it will return a status code as -1, and will print that there is some error from the server side on the serial monitor. So, and then we'll end the request. So, and it will return a payload. So payload is nothing but the data received from the server. So this is the function which we have used here. So one by one, it will get the data, each data, temperature, humidity, and pressure, and then it will be printed on the serial monitor one by one. And again, as you know that these are the OLED functions. So as soon as we get the data from retrieve the data from the server, we'll display that same data on the OLED. So these are the OLED functions which we have used for displaying those data on the OLED. And then here is an interesting thing that after displaying that data on OLED, we'll be logging that data into the spreadsheet. So when we use a spreadsheet, we manually add the data. But to automatically log the data into the spreadsheet, so there is one extension called app script. So using that app script, you can automate that thing. You can automatically log that data into the spreadsheet. So here I have written one app script. So what it does is it automates the process of logging the data into the spreadsheet. So this is basically JavaScript. So here we have a do-get function, and so these APIs are very easy to understand. So we'll go one by one. So here we have this main spreadsheet, and these are the different sheets we have in a single spreadsheet. So this is basically the current working spreadsheet. So using this API, you can get the name of that current working spreadsheet. And if you want that data to be stored in the sheet 1, then you have to pass that name of that sheet to the sheet by name function. Then you will get a sheet object. So I want that the temperature value to be logged into the temperature column. I want pressure data to be logged into the pressure column, and I want the humidity value to be logged into the humidity column. So I will need these headers to log the particular data. So I will get the headers of the particular sheet using this function. Then I want the latest data to be updated as in the new row. So first data will log here, second data will log here. So the latest data should be logged into the new row. So we'll get a last row in a last row variable. Then as soon as we get the headers, so we'll basically also store the current timestamp at which we are logging the data. So if the first header is timestamp, it will automatically store the current timestamp, and the other parameters will be the temperature, pressure, and the humidity. So according to the data we receive, it will automatically log the data into the particular column. So this is all about the logging the data. Then the next thing is we want the alert notification if the temperature value, let's say a temperature value is greater than 75 for the 70. So if the latest data which is getting logged into the spreadsheet is greater than the 70 or 75, we want alert notification. So this is from where I am getting that latest data is So the temperature is the last. The temperature is the last column. So using get range function, I will so that will be the latest value, obviously. So last row and the last column, and it will return the value at that particular cell of the spreadsheet. So it will check if it is a greater than, let's say, 65. So it will go inside this if condition, and then I want that and if it is greater than the 65, then I want it to send the alert notification to the user. So I have stored the email IDs in emails sheet. So I want these peoples to send notification. So it will get the mail IDs from this sheet, and then it will send the emails using mailapp.sendmail API. So here, this is the message to be sent to the user, and this will be the subject. So this is about the app script. So using app script, you can automatically log the data into the spreadsheet, and you can send the notification to the user. So we'll quickly see the demo. So the server code is already flashed into the ESP. Sorry, if I may go. It is connected to Wi-Fi, and we'll quickly flash the client code. So as you can see that the data is also displaying on the OLED, and the data is also logged into the spreadsheet. So that server is sending the data to the client as soon as it receives a GET request from the client. So currently the temperature is 29. We'll use a hair dryer to increase the temperature, and we'll see if the people are getting the notification or not. Now this 53. This is the threshold limit. So you people can check your email if you are getting notification or not. So here you can see that I am getting notification that that the temperature has crossed the threshold value, and right now it is giving the current the temperature value.
So whoever has put their email addresses, did you all get an email? Should have got. If you have, please raise your hand and you will know that. Right. So that's how we just implemented a simple system. So just to sum up what we actually did. So what we basically did was interfaced the sensors, right? And then after interfacing, we had to have a medium to send the data to Google Sheets. And the medium we used was Wi-Fi because we have used ESP32. ESP32 has provision to use BLE as well. But since we are using, we need to send the information to a cloud or a Google Sheet kind of an environment, you will need some way to get through the gateway. Okay, so that's why you use Wi-Fi, and then a simple way to push data. Like I said, there are multiple protocols available for building your IoT systems. So here we have used HTTP. HTTP is very simple. We can push data and then at the same time get the data as well. So this was the basic setup, and you can definitely do this simple setup maybe in a day or two using the libraries that Arduino provides. Yeah, so does anybody have any questions related to the complete demo itself?
Hello, Lohit. There is a question on chat saying that can I get a recording of this session?
Recording of the session, I think we can, right? I'm not sure if we can do the recording.
The recording of the session, you can contact Professor Ram Pasu.
Yes, so what we will do is after all this is over, we can we will put these videos online, for a while, and maybe you can download things which you want. I mean, assuming that's okay with the speakers.
Yes, it's totally
fine.
fine.
We'll work out a way. So I think if so, give us some time after the conference is done. So we will work on it. So you may send me an email after a week or something.
Yes, thank you. And Amol Patel sent me a direct message. So he's asking, is it possible to plot these data? Yes, Google Sheet has ways to plot our data as well. But yeah, it is definitely possible. So we have not done that part here because, yeah, I think Professor Rajbabu will tell more about that. Yeah, so any other questions? Okay, I'll just hand it over to Professor Raj Babu. So yeah, I think he has something to share.
So, good evening, and yeah, so let's continue. Of course, it seems like we are running ahead of time, so I thought we would take some more time, but hopefully that's not an issue if we finish early. But let me try to. I think there was a question, and I'll say whether I think the question was whether to draw this time series plot. Of course, so right now I think whatever Lohit presented was directly logging into the Gmail or a Google Sheet. We haven't directly plotted the Google Sheet, but I think so. I mean, I think I don't know, like with the interest of the participants, if it is not too much, I may need to connect another machine and show a few things. But before that, I mean, depending on the interest, of course, you want to talk about this?
Yeah, since we have time, there are a few use cases that I would like to show. So this is the Simul ID. So like I said, there are a lot of toolkits available which you all can use. And so this is a simple Mario game that uses the OLED display. So this is not related to IoT, but let me show another example which makes more sense. This is another use case that we did. So you can compose music, using this is a very crude way, but it basically exhibits a use case of this. Yeah, so this was an interesting thing. Slide. Yeah, so this is a face detection that we tried. So this is more of an IoT-based application where you want to deploy this maybe at your home or at an office place at a low-cost surveillance system, right? So these are the different use cases that we have tried with this board. So there's a lot of potential on this board. You can definitely use to build your simple IoT-based systems. Okay, I'll switch. I need to log out.
Okay. Yeah. Sorry, what is it? Yeah, am I audible?
Yes, sir.
Yeah, okay. So this is basically to just kind of address that question, though we don't have a great demo of that, but I just thought this was something which was something this will be something convincing to really show that though we kind of said the 1 minute, I just make sure that I'm sharing my screen. Yeah, so my slides, yeah. So just though in the beginning, we kind of had this comment that we are mainly going to look at communication, sense interface, and sensors, which is what I think Lohit had shown so far. He just started or initiated a kind of first step into do any kind of analytics. And I think thanks to Amol, he did ask the question. We were kind of half prepared, not fully prepared. But I'll take this chance because we have some actually more time. I'll not be able to do entire justice for the entire 1 hour, but I'll just show that it's not very difficult. We are very close. And an attempt to do this was we could have probably done it on the Google Drive, but what we instead did is we thought since mainly students and anyone who's getting into such fields would be familiar with Python, and and then once you know Python and few things in between, the data analytics part becomes much more simpler and easier, right? So with that intent in mind, of course, I think as most of you are with engineering background, you would know that whatever was shown so far was kind of just raw data. Just sensors were connected to the microcontroller, data went into the microcontroller, and that was just logged into the Google Drive. And if you had paid attention, and some of you may not have not attended the session which Professor Siddharth had, so he did show or talk about how, irrespective of what data is, you need to know what you want to do so that you could analyze the data in a better way. And towards the end of his speech, he showed both kind of data, one data which was varying quite a bit around an offset, and he talked about something called this Allen variance. So I'm myself not a sensors person, but I think Allen variance is kind of to kind of decide what would be the best length to look at or the snapshot of data to look at. So with that in mind, and more from a signal processing point of view, I thought I'll share this, which is not exactly the data which was logged now, but I think we could do it and it's not that difficult. So let me just try to show what we did. And so that will convince at least Amol and those of you who would really want to do things like as Lohit said in 2 days. This will, in 2 days, you will also be able to maybe plot and do something, right? So let me just go to that my desktop and share what we try to do. Of course, this is assuming that you know a bit of Python and or maybe more of Python, and you have interest in just writing a few lines of code, really few lines. This took about 10 minutes to write for someone who's very familiar with Python. So what we tried is maybe let me just show the data. I think that this was not like the data which Lohit showed now, but it's not very difficult to do it, right? So this is the data. We just took the temperature part of the data, the same Google Sheet. It was just updated yesterday. So we called out the time, and unfortunately we didn't know about this 60-degree with or the hair dryer being blown, and that's why the temperature went high. We didn't know it. So we thought these are all outliers and we just removed it. That was just what as signal processing engineers we wanted to do. But despite that, you can see that there are some variations in the temperature. And what we said, okay, let's see if I am a signal processing person looking at such data, what would I want to do, right? Typically, not giving too much value to how the sensors sense data, we would try to obviously filter it, right? And if we could kind of, let's say this, I think my screen is visible, readable, I think. So, yeah. So like as you can see, so you use some basic Python scripts or libraries. The main one being this signals, so that we could use any reasonable or actually very good filters. That's what we're going to use. So we read this data, the file, a similar file, which is what you saw in that Google spreadsheet, but we only read the temperature column from that sheet. And once we read the temperature, we thought there were some outliers, like about yesterday, there was some odd data. So we said anything less than 170 is some valid data, and we wanted to see how this data looked like. And then after looking at this data, we also wanted to see, we want to smoothen or do something to this data, right? So we could do different kinds of filters. What we looked at was to use a simple single pole IIR filter. And those of you, I'm sure most of you are familiar. We have a filter of this form, which is essentially this 1 minus alpha here. This is a scaling factor. Otherwise, it's a filter of 1 by 1 plus alpha z power minus 1. Right? It's an IIR filter with the pole at alpha. Right? And depending on this value of alpha, it says, is this pole closer to the unit circle or far away from the unit circle, right? As it goes lesser and lesser, like 0.9, 0.8, and 0.7, we're going away from the unit circle, and it's going to do a less of damping. So we tried either to use this data, which is an IR filter, or moving average filter, which is an FIR filter. Again, we could choose, like as I mentioned, what length of filter to use, how much of data to use, all depends on the specific application. In this case, we just chose a window length of about 60, and this will give us a simple averaging filter of over 60 samples. And so we can see once we have all these things, which is very easy if you do have done some DSP, and if you use Python, you can use this built-in function to either use an IR filter or a FIR filter, and then we do the typical thing: we plot the data and see what happened or what would happen, right? This is just without doing much change. This is what happens. So if I think you can see the screen, essentially. So I think the original data which was logged was in this blue data. As you can see, there are spikes in this blue data because this there was temperature variations, but not as high as the one which Rohit showed because of a hair dryer. But still, there were some variations. I don't know what these variations were, but in any of there were variations, and that is the underlying blue curve. And then we applied this IAR filter with a kind of aggressive smoothing. So that is why you can see this red line, which is point with a alpha coefficient of 0.99, which has smoothed out the data quite a bit, right? Is this good or bad? It depends on the application you're looking at and what is that you really want to do, right? But nevertheless, this is what this filter with an alpha 0.99 does. And we can see the FIR filter, which is again shown as a plot, which is in green curve here. Here, the length 60 didn't do too much of, did not affect too much, but it did still suppress the peaks, which are quite high in this original data. And then you can see this green line. I think maybe I can zoom a bit. Maybe. So I can zoom a bit, and you can see the variations which have happened because of using this FIR filter, right? That green line here is corresponding to the output from an FIR filter. And you can see that the actual data varied, right? Of course, is this right or wrong is something which we should not be just doing it based on what we see here, because maybe the application really would need maybe it would really need to capture these variations. And what we have done is, well, we don't need this variation and removed it. And when we did this IIR filter, we had a very aggressive damping factor. And you can see that it's almost smooth whatever we wanted to kind of see. Maybe these variations are important. Okay. This is just to say, since the question was asked, yes, we could just take this data. The only thing we had to do was in this data file, of course, we could read, and if you're very savvy Python programmer, you could directly read from a Google Drive sheet, get all the values and plot them. But for just keep it simple, we just copy pasted that data from the sheet into a text file and then read that file, did some basic filtering, and we get this data, right? Of course,
does data analysis stop here? Actually not, because this is just the starting of the data analysis, right? So now what we have done, we have processed this data, or in some sense pruned this data to make it less noisier, right? That's all we have done, with the caveat that this is probably not a good thing to do, but we still did it. So once we have this, let's say this, I would say pre-processing done, though it is after the sensor, it is pre-processing for any of the next steps in analytics, right? Like we may want to analyze in the sense like, is the day, like for example, now if you go back to the data which Lohit had showed, which has temperature, humidity and pressure, maybe based on that we could say, was the climate today pleasant, or was it too hot, or was it too humid? Few other inferences can be made, right? Those need data analytics, and I'm not going to talk too much more about it, except saying that given that data which was logged, it's next the role of the analytics engineer or a machine learning person who wants to look at this data, analyze this data, extract certain features out of this data, and then make some decisions, right? And since this is ICC and some of you probably, or most of you have a controls feedback, you may also want to close the loop in some sense. When the demo was shown, it was just an alert to you, but that doesn't help in practice. So you have to probably close the loop, which means you have to send back that data to an actuator, where the actuator may turn off one of the source of this increased temperature, which is possible in a demo like setup, but in practice that may not be possible. In any case, the loop closure, which is probably very important from a control point of view, unfortunately we couldn't get to those parts because we didn't know whether I'm sorry. Yeah, so we kind of overestimated the time we wanted to present this, and so we couldn't get to the loop closure part. But hopefully, at least that I think answers part of Amol's question. Let me get back. Yeah. So yeah, I think Amol or anyone else have any other specific questions? So we have some more time. I can answer, though I don't have anything more to show. I think whatever I wanted to show, I'm glad that I could use that as well. But if there are any specific questions, I think we would like to use this time to answer. And then because we only have a few more things I want to talk about. Any questions? Yeah, so yeah, you're right. Sorry, I thought your microphones are unmuted. But anyway, yeah, I think Amul has a follow-up question. Is it real time? Yes, it is. This the one which I showed is not real time, but I mean, I think even if we had known, it's not very difficult to make it real time. Again, the tools which are used probably could be based on whatever Lohit showed, but it will need a bit more work. And I agree, yes, this was only to kind of show that this is possible, but I don't think it's very difficult to make it real time. Yeah, thanks at least for one question, and which helped us show the part which we thought we would skip anyhow. Thanks, Amol. Anyone else have any other questions? Okay. If not, I think Professor Ramakrishna, you're there. Is it okay if we, I mean, I have one more slide to talk, but is it okay? I think because I don't know if there are participants who may come later and join, but I think we are almost done, and I'm going to end this session. Do you have any specific comments or?
Yeah, Professor, I have one question. This is Sachin here. The programming code was shown in the C language earlier, and now the data analytics was in Python. So is it necessary to have to know both the languages, or
Yeah, that's a good question, Sachin. Actually, no. So the reason, so I think eventually when these systems get deployed, we would have to go to C and maybe, yeah, I think more efficiency, which is like to meet real-time constraints. But the reason why I showed plots in Python was for analytics. To do analytics, the starting point is you have to build models, understand the data, and come up with some kind of quick. I don't want to say quick, but something very flexible where you have a lot of tools available. And in the current status is with Python and the frameworks around Python like PyTorch or TensorFlow and few other things. Data analytics is very easy to do in Python. So that way you kind of you have all your data analytics done, you build up whatever analysis you want to do, build models, and then come back and bring it into the real system you want to deploy. So yes, to answer the question, no, you don't need to do things in Python. If you're very good in C and if you're industry working on these problems and everything you have is in C-like environments, all that can be done in just C. But if you're an engineer looking at data analytics also, I think it's still very easy to do it in Python because your learning curve, I mean, your time to kind of analyze these problems is much shorter using Python or MATLAB, for instance. So that is why we just chose that, because we thought this would be the first step.
Okay. Yeah, thank you.
Yeah. Yeah. Any other questions?
I have one question, sir. Means it is in continuation with what Mr. Sachin asked. So do we make a dashboard or other GUIs in Python itself?
So yeah, I think maybe that is a good question, which means, so yeah, so the way we presented or whatever we presented today was kind of a system which is kind of local, which is the Arduino kind of system, which we didn't go into any of the existing IoT platforms, so to say. So there are some IoT platform like Thingsboard and I think Azure, Amazon Workspaces, all of these kind of more commercial and semi-commercial platforms provide an environment which is very similar to what we had presented, which Lohit has presented in terms of the Arduino setup. And they provide all these dashboards, so-called dashboards. Basically, dashboard is a flashy way of showing the plot, which I showed here. But nevertheless, all these platforms provide such a framework. So if you want to enable such dashboard-like devices, and I think even Arduino has probably come up very recently with an IoT framework specifically, where it gives access to the use of cloud. So it's not very difficult even within the Arduino platform to build dashboards, which are just GUIs to present the data. Again, the question of real time is still there, but I'm sure it can be done almost close to real time in terms of at least displaying data on a website, or even for that matter on a mobile phone. So you can connect your mobile phone to this cloud service, and any data like the one which Lohit showed with a local sensor, this can be pushed to an internet, and from that internet you can look at in your mobile phone, right? So, and then that can be a dashboard. To answer the question, it doesn't need Python. You can just do all this in this. These dashboards are already kind of some built code and built applications which can just be used. You don't have to do much.
Thank you, sir.
Okay. If there are not any more questions, so I'll try to just summarize. So basically, hopefully with this, the last session, and including the previous two tutorial parts, part 1 and part 2. But of course, I was there along all the 3 sessions. I think the overlap between all these 3 sessions were only very few people, and I'm not able to. I know there are 2-3 people I saw in all the 3 sessions. So thanks for all of them for sticking there with us and going through till the end. But anyhow, so you would have got some understanding of what an IoT system is, though not all aspects of IoT, because there are many more things which an IoT system involves in building an IoT system. From the first talk, you probably got a sense of how important sensors are and how do you design such sensors, or what do you consider when you make your sensors choices. At least one thing should be very clear was your application really drives these sensor choices, and that's why it's very critical as to what you want to do, and the sensors make a big role, play a big role in it. The next one, when Professor Gaurav presented, was on communication and networking. Though I think he tried to build also some basic understanding of communication and network aspect, and then touched upon things relevant to IoT. Some things might not have been very obvious, but he did focus on few of the more recent standards and specifications which are used in IoT. For example, the LoRa and I think Sigfox something. So which means that it's not everything, but some sense of what this networks is. Though we didn't use all the sensors mentioned in the sensor talk or all the networking aspect presented in the communication aspects of IoT, the final hands-on session, the main intent was someone who has some basic background in engineering can get started with a microcontroller based system to set up a simple IoT system. We also showed not just one microcontroller, but there are 2, one acting as a server and one acting like a client, but that's not necessarily the setup. Both of them could communicate to the internet or some other local server, log data there, and that data can be analyzed. Though we didn't do too much of analysis, I just showed you how that data is still useful, and hopefully with all that hands-on session, though you couldn't do it your own, hopefully you had some sense of how an IoT system or what it takes to set up a basic IoT system. As was already mentioned, we will try to share the video, the recording of this video, and also see if we can some of the framework codes which we used along with this microcontroller system. We'll see if we can share that as well, at least, or if someone is really interested, do email me and we'll see how we can enable you to kind of continue your work on IoT. Okay? So with that, and last but not least, I first thank all of you for attending this session till, though it's not 8:38, at least it's 8. So thanks for sticking till the end. I'll also like to acknowledge the kind of opportunity provided by organizers of ICC 2021, which gave us a platform to share what we have about on IoT, and also the Technology Innovation Hub on IoT at IIT Bombay, who sponsored this tutorial as part of ICC. So thanks to them. And just as a point, those of you who are interested in IoT and doing research in IoT, they do have a research front, and you should just look up them to see if there is something of interest to you. And last but not least, I'd also like to thank the department which I belong to here, was to provide the support to most of the faculty who presented this session, and also the current lab which is we are conducting the session from. Thanks to all, and of course the Yantra team, Lohit, and others who supported in conducting this demo in a very smooth way. Hope all of you benefited from this. I think with that, I like to thank and thanks. And I think I'll end the session unless there are any specific questions. I'll just wait for a minute. If not, I think we are done. So let me just check. I think the session. Yeah, thank you all for being there. Thanks. All are still there. Yeah, Pratibha, so I'm done. So if you want to end the session, you could go ahead and end the session.
Yes, sir. I will end the session.
Yeah, thank you.
Thank you, sir. Good day. Good evening.
Yeah, bye.